Today we're going to take a look at a special kind of stoichiometry used to figure out the concentration of solutions from a chemical reaction. This is called a titration. What you're looking at in front of you is a titration setup and how we would go about figuring out this concentration. So we have our retort stand, which you guys have seen when we did used funnels for filtration rather. We have a clamp here that's just going to hold our burette in place. Underneath the burette we have our sample in an Erlenmeyer flask. It's really important to note that that's an Erlenmeyer flask and not a beaker, and when we get to the actual titration I'll explain to you why we use the flask instead. There are two solutions involved in a titration. The solution that's placed into the burette, which in our case is sodium hydroxide, is called the titrant. The solution that's placed in the Erlenmeyer flask is called the sample. We can do two different types of titrations, or we're going to look at two different types. We're going to look at something called standardization, and then we're going to look at sample analysis. When I say we, I mean I'm going to look at standardization. You guys are all going to do the sample analysis. What I'm trying to do in this standardization is figure out the concentration of the sodium hydroxide that's in the burette. Now, the issue with sodium hydroxide here is that we cannot make a solution out of it that has an exact concentration. The reason for that is because sodium hydroxide is so reactive and it reacts with the water vapor in the air, so that while we're weighing it to get the mass that we need to make the solution, it actually increases in mass as it starts to react with that water in the air. And so for that reason, we can't get a solution that has a super accurate, precise, known concentration. For that reason, we have to undergo this process by titration, which is called standardization. To standardize a titrant, we use something that's called a primary standard. And all a primary standard is a solution that can be made of exact known concentration. So it's made with a very stable solid. And that solution that we are using today is KHP. The formula for KHP is given to you on the lab handout for standardization of sodium hydroxide. KHP is potassium hydrogen phthalate, and you are provided with the formula for that as well as the balanced reaction. What we're going to do here is take a look and figure out what is the concentration of this sodium hydroxide, and B, learn how to properly do a titration. In figuring out the concentration of this sodium hydroxide, you guys will then go ahead in your labs over the next few days and do some sample analysis. And we're going to be analyzing two different consumer products. One is vinegar, one is aspirin tablets. And you will be following these exact same procedures in your sample analysis for how to do a titration. So be sure you pay close attention. Okay, so what I'm going to do is first prep my burette. So before I use it, I need to make sure that it is analytically clean and ready to go for this titration. So burettes should always be put away at least edibly clean, and so what I want to do is just make it analytically clean. So I'm just going to add some distilled water into the burette. I don't need to fill it up all the way. Just about 10 or 15 mils will be fine. So you can see how much I've added there. And then what I want to do is make sure I rinse the burette so that this distilled water touches all the walls of the glass and is able to capture any ions that might be lying left behind. So I'm just going to turn it horizontally over the sink and rotate it. And we can have a little bit pour out there. The other thing that I want to do is make sure that the distilled water runs through the tip of the burette so that gets analytically cleaned out as well. So I'll just simply open the stopcock, let the water run out, and make sure it all runs out. Now, the small problem that I have with that is now my the burette is wet. And the issue with that is that it's going to, any water left behind is going to dilute the concentration of my sodium hydroxide. So to continue on in the prepping of the burette, what I want to do is then take some of my titrant, and so in this case it's going to be sodium hydroxide, and I'm going to do that same process that I did with the distilled water with the sodium hydroxide. So just pouring in maybe 10 to 15 mils, and rotating through so that it can hit all the walls of the glass. Now this stuff is fairly dilute, so that's why it's okay to be in the sink. Not ideal, but it's okay. And then again, run through the tip as well, so that what is remaining in the tip is sodium hydroxide, which I'm going to be using for my titration. Run that all through. And now my burette has been prepped, and I am ready to fill it with titrant and start my titration.